I want to welcome you to this YouTube channel. It's about macroeconomics, anything about macroeconomics. And I started it due to my love for macroeconomics while taking my degree, but I didn't know where to begin or how to continue doing what I love. So after a series of courses on macroeconometric modeling and macroeconomic and professionally, I also worked for so long as a macroeconomic modeler. So I found it worthwhile to share these practices. How can you be engaging in macroeconomic modeling? And that's what now I'll be showing you. This is what I was doing, this is what I have been taught. So it will be very important for you in the field of macroeconometric modeling and forecasting series. So let's go first to see what is expected of you. Now, the Macroeconomics Academy will help you to construct and use a macroeconometric model to your economy. Not necessarily a developing one, but also it can be the case of a developed. So, how do you construct one a macroeconometric model? Very important. So, specifically, you will understand the different stages in the development of a macroeconometric model. Yes, there are various stages that have to be taken for you to come up with a macroeconometric model. Then, after you understand the different stages, now you'll be in a better position to build a macroeconometric model. And based on that model, you can make now forecasts based on it. And finally, you'll be in also better position to conduct simulation and policy choice analysis exercises. Now, the objectives are that now in this particular platform, we'll be using the case study of a Senegalese economy. Now, and since we are using a small macroeconometric model, there are cases whereby you use mega or large macroeconometric model. But for the purposes of this course, I'll be showing you how to do that using a small macroeconometric model. As a result of that, you'll be in a better position to build your capacity in macroeconomic modeling. And also the case study that we're using of a Senegalese economy, you'll be better, you'll be able to understand the process by which a macroeconometric is constructed and used for forecasting and economic policy impact analysis. You'll be seeing, for example, if we increase our tax by 10%, how will that affect all our variables from private consumption, private investment, government expenditure, exports, imports? How are they affected by a simple fiscal policy uh, a shock such as a 10% increase in tax? So that is the focus of this module. So to begin with, I would like to show you now how our macroeconometric model looks like. So this is what now we define by a macroeconometric model. Now we have five key equations that will be explaining or they are behind our macroeconometric model. Now remember when we were talking about macroeconomics theory, we talked about the gross domestic product, a very important equation that was defined by one, private consumption, or two, we had also private investment, we had exports, we had imports. And now for the purposes of a macroeconometric uh, exercise, we have what we call the change in inventory. Now the four equations that we have, they are what we refer to as the behavioral equations. Now when we talk about private consumption, when we talk about investment, when we talk about exports, when we talk about imports, this is what we refer to as behavioral equations. Now, the last equation is what we could refer to as an identity equation, or what we call the resource use balance. In other words, it balances our GDP now to all those behavioral equations that we have. So, what we have here now is to explain. Now, it depends with the acronyms that you want them to present, to stand for your actual variables. So for my case, I'll be using CP to present consumption, IP to present private investment, exports, EXPT, imports, IMPT. And of course, we have the lagged variables. Like for example, here CPT minus 1 is a lagged variable, IPT minus 1 is a lagged variable, TCER, that is a real exchange rate. Then we have INC, that is uncertainty. Then we have what else? I think that's okay. Now, for you to have a macroeconometric model, now the equation, there are standards that each equation, or there is a structure that has to be followed for each and every equation, and that's the next thing that I want to now to explain. Remember, if you look at this equation the way it appears, the five equations the way they are, you can guess that I'm using the Keynesian approach. So in other words, I'm basing this model on Keynesian type of model which focuses on demand. Now, for the first equation, which is private consumption, we usually say private consumption is explained by income, if you remember the Keynesian approach. Now, the first equation could have included, of course, it is explained here by uh, gross domestic product, which is PIB, and at the lagged variable of itself, which is CPT minus 1. It explains the equations. Now, this equation could have included other parameters such as the real interest rate. Uh, that one will be now talking of a neoclassical approach, or it could have other parameters such as dependency rate or demographic factors. They also affect consumption. So that does not mean that my equation is actually has to follow that. You can, as long as you have data. If you have data on interest rate, if you have data on demographic factors, then you can include those parameters. But for the case of this scenario, I'll be using those two to explain my private consumption. Then for private investment, now it is again specified according to Keynesian logic, and it depends on what we call the accelerator effect. The accelerator effect has that impact of boosting investment. On the other case, it is also affected or impacted by uncertainty. Uncertainty normally has a negative impact on the incentive to invest. So in this case, we have included INC. Also, this one could include other parameters. As long as you have data, then you can use those parameters that you have data for. But for the case of my analysis here, I don't have data to support that. That's why I left other parameters. Then we have exports as our third behavioral equation. Now, exports are explained by GDP. Of course, you can see GDP is common for all the four behavioral equations, and also real exchange rate. Now, remember, exports are specified as a supply function. In other words, they depend on the productive capacity of the national economy. How productive is the country? The more productive it is in a particular area, then the more exports that they are in a position to produce. Uh, then we have the imports again. They are a function of uh, gross domestic product and real exchange rate. Now, the import demand here depends on the level of domestic activity. What is the level of domestic activity? The more activity that we have, or the more the activities that we have in that economy, then the more imports that that country will be bringing in. And also, the other thing that affects import is the competitiveness of the locally produced goods relative to the foreign produced goods. How competitive are the locally or the domestic produced goods vis-a-vis the foreign produced goods? Now, the last equation here, which we call the resource use balance, is actually uh, an accounting equation, and it defines the resource balance. That is the equality between aggregate supply and aggregate demand, of course, in an open economy. So, having given you that, now the next thing I would like you to take you through is If you look at our equations clearly, you can see, like for example, in the first case, we have epsilon t, we have mu t, we have vt, we have wt. What are those? Those are what we call error terms. Now, why do we have error terms in our equation? Why do we have error terms in our equations? Why are they so important that they have to be included in those four behavioral equations? Now, the error term is what we call the specification error of the model. In other words, it collects any omitted explanatory variable. So, for example, in our first equation, we may have some omitted explanatory variables. So the role of epsilon t, which is our error term, is to collect them to make sure that our equation now meets the standards despite the equation missing some of those explanatory variables. Now, another important thing to note about an error term is that it is statistically significant. And the reason why it is statistically significant is because it captures problems with error measurement of model variables. So any error measurement of the variable will actually be captured by the error term. So that is the most important thing, or that's why we include our error terms in behavioral equations. Having said that, the next thing that is very important for us is to know the uh, the endogenous and exogenous variables of this model. So the next thing that will be very important is for you to identify your exogenous and endogenous variables. So we usually say the exogenous variables are those that they cannot be explained. They are explained by external factors uh, beyond the model. But endogenous variables are those that can be explained, or they can explain the model. That is the internal. Looking at having said that, our some of the exogenous variables that we have here, those that cannot be explained by factors within the model. One, we have the government expenditure, GT, or what we call the public expenditure, sorry. And then we have uncertainty, that is another one. Then we have the real effective exchange rate, TC. For me, I've denoted it as TCERT. Then we have the lagged variables, CPT minus 1, IPT minus 1. Then, of course, the unit vectors is epsilon t, mu t, vt, wt. Then, when we talk about endogenous variables, they are what some of them in this model are CPT, private consumption, IPT, private investment, EXPT, exports. Then we have imports, we have gross domestic product, PIB. Then lastly, I think that's all. So that is for our endogenous and exogenous variables. Having said that, now the next thing now will be to try to show you now the Excel sheet that I'll be using for this analysis. Of course, it corresponds to those variables we have. Our data runs from 1972 all the way to 2002, and for purposes of forecasting, I've left 1998, 1999 all the way to 2002 blank for all our variables. So that will be the exercise that will be for this part of this tutorial. Now that you know the endogenous, exogenous variables, and now you have a clue of what a macroeconometric model is, the next thing is now to help you visualize or to graphically represent our exogenous and endogenous variables to see how they behave. So for this exercise, we'll be using what we call EViews. EViews is a very friendly statistical interface. And the good thing with EViews is that you don't need to know any coding. You just use the interface and it gives you results. So that is the good thing about EViews. Now, for the case of so let's create a new file. frequency. Of course, looking at our Excel spreadsheet, it is in years. So we go back here and denote this as start date is 1972, end date is 2002, and of course everything else it's dated. So you have to look at your data. Is it unstructured? Is it dated? Is it balanced? So it's very important for you to define that. For in the case of our data, it is actually dated. Give it a start. So dated, and then the next thing now will be to load our file. Let's load our file. Of course, I have to check where I've stored my file. Here it is, Senegalese model. Aha, there we are. So of course, is it okay? We have the year, we have the variables. Then we have okay. Then we finish. I do not to link any imported series to external, so I leave that as that. So let's look at it. So you can see all our parameters or variables are there, from private consumption all the way to change in inventory. So we want to map them. We want to graphically see how they all appear in this when mapped graphically, to give us a rough idea. Are they constant? Do they have a constant trend? Do they have a rising trend? Do they have a decreasing trend? That is very important if we are to know, or if we are to predict how whether they are or integrated. Are they stationary? Are they not stationary? So that's why we do that. So let's start with our CP here. Of course, you go to view, then you say graph. Hmm, it's taking time. Then you go to line and symbol, or here in graph type you select line and symbol. That's the only thing you need to do, because you just need to see how it looks like. Of course, you can see it is not stationary. It has an increasing trend or a rising trend. Then we move to the next one. Let me use style. The next one is IP, private investment. It is, open it, then go to view, then graph, then line symbol. Okay, that's how it appears. Of course, you can see it has a rising trend, but over here 1972 all the way to 1980, there was some constancy, and then from there it began going up. So that is it. Then let's look at our exports. Again here, Windows style, exports. So the good thing again with EViews is that you can organize your work in uh, in uh, in in in, uh, in interfaces. So if you need to get to any, you just go maximize and then you're good to go. So let's look at exports. How do they behave? So we need exports here. Exports, graph. There they are. They seem to exhibit some form of constancy, but somewhere in between 1986 all the way to 1998 there was a rising trend. Let's go to imports. You can see how EViews places, it's like a form of dashboard, so it looks very presentable. So let's look at imports. You go to view, then graph, take some time, then there we are. Then okay, look at also imports. From 1972 there was a sharp trend, increasing trend, and then they dropped dramatically. Then you can see again them rising, trying to establish some constancy here from 1990 to 1992. Again they fell in 1994, and then from then henceforth they have been rising all the way to 1996, and then some form of constancy. So that is for imports. Let's see how government expenditure appears. How, where am I? Window, tile. So we need to see now government expenditure. How has it been appearing? View, then graph, then we have that. Of course, you can see it has been rising. I think for now you can gauge and tell which variables have a constant trend, or which variables are stationary. So far there is none. It's either they're increasing, they are decreasing. So far we don't have any that displays that. Let's go to uncertainty is our next view. Graph takes some time. Then we have that. Let's see how it behaves. Also this one somehow, but it's also not stationary. Let's go to uncertainty. GDP. We have not looked at GDP. GDP view, graph. Look at our GDP, an increasing trend. Let's look at our change in inventory. Change in inventory. Go to tile. This is my work file. Tile. Then we go to change in inventory. Here it is. Let's see if at least this one can display some form of stationarity graph. There it is. Yes, of course you can see now this one behaves somehow. There's a level here that it was trying to attain. It goes back, bounces back off, then tries there, bounces off, goes. At least this one now you can see it somehow stationary. It has some properties of stationary. This now we are done. I don't think if there's any parameter we have not looked at. Now that you have an idea of how your parameters or your variables look like, as in they have an increasing trend, do they have a decreasing trend, do they have a constant trend. Now the next thing that we want to do is to determine the degree of integration of the variables in this macroeconometric, and the only way to determine the degree of integration is using what we call the Phillips-Perron test. In other words, we are conducting the test for stationarity. You cannot work with data that is not stationary. You will get spurious results or wrong results. So for us to make sure that the data that we are analyzing gives us results that are reliable, that are accurate, therefore we have again to conduct stationarity test for stationarity for our variables. Now for us to do that, there are things that you need to know before you even begin the exercise of testing stationarity. One, when using what we call the Phillips-Perron test. Now, we usually say H naught represents a process X which is non-stationary. Now, if you go to H1, therefore the process is stationary. And the decision rule for this is that if the probability value is greater than the alpha threshold, then the null hypothesis of non-stationarity is not rejected. In other words, we come up with the rule that variable x is non-stationary. Now, if the probability value again is less than or equal to the alpha threshold, then the null hypothesis of non-stationarity is rejected. In other words, variable x is stationary. So here we base the probability value versus the alpha threshold. If the probability value is greater than the alpha threshold, then we can say that the null hypothesis of non-stationarity is not rejected. In other words, variable x is non-stationary. On the other hand, if again we find that our probability value is less than the alpha threshold, then the null hypothesis of non-stationarity is rejected. In other words, variable x is stationary. Now, the test is based on three types of models. One, a model with a constant. Two, a model with a consistency and trend. And three, a model without both constants and trends. So you will only delve on one of these. You cannot use, it's either a model with the constant is significant, or two, it's a model with consistency and trend which is significant. In other words, we rule out number one. Or three, it is a model without constants and trends. In other words, we rule both of them. Having said that, let us now conduct the test for stationarity for our variables. Now, I expect at the end of this exercise, you'll be having an Excel sheet or a table that appears like this mine. Now, in other words, we have conducting stationarity at level or fast difference. Now, when we first conduct stationarity, we call that stationarity level. Now, if a variable is found to be stationary at level, that's how we write it. In other words, we have variables, we have constant, we have trend, and the probability values associated with those variables. Now, if that variable is not stationary at level, then the next step will be to ascertain or to find out if it can be stationary within the first difference or the second difference. So that's why we have this column of first difference. Now, in most cases, you find variables are stationary at difference. So let us now begin with our first test for stationarity using the Phillips-Perron test, and with our first variable will be CP. So we want to ascertain whether CP is stationary or non-stationary at level, and if it's not stationary at level, then we make sure it is stationary either in first difference or second difference. So let's go to quick. There's a tab here written quick, then series statistics, then unit root test. Therefore we specify our series is private consumption. Okay, then you specify is it in level. Of course, we are beginning in level the test type. For purposes of this, you can use the others to test. We have the ADF augmented Dickey-Fuller, we have Dickey-Fuller, you have Phillips-Perron test, you have Kwiatkowski Phillips Sheen test, but for this purpose I'm using Phillips-Perron test. And of course, you have to begin with trend and intercept before you move to the other. So here I'm going to use trend and intercept to see whether our model is statistically significant. Now, for the Phillips-Perron test, you can see it is statistic. It has a probability value of 0.2636, in other words, 26.36. Remember, our alpha threshold is 0.05. In other words, our probability value here is greater than our alpha threshold. That means that we cannot reject the null hypothesis that our private consumption are non-stationary. Now, remember we have said we have to check whether we pick it with a trend or an end with an intercept based on the probability values and the level of coefficient. Now, looking at the trend, you can see it is 0.0151, which is less than 0.05%. Therefore, we keep our trend. Looking at our constant, it is 0.007. Again, it is less than 5%, and its coefficient is actually different from zero. You can see we have 380.138. Therefore, we keep our model with both the trend and uh, the coefficient. So that's it. And if you go back to our Excel table that I had populated earlier, you will find that our variable CP at level, it has a probability of 0.264, but it is not stationary. So let's make it stationary now. So let's make it stationary through levels. So let's go to levels. So again, you go back to series statistics, unit root test. Then we are dealing with the private consumption still. Then we say fast difference, but of course now we are going to test with a trend and intercept. So let's see how it behaves with a trend and intercept. Now looking at the Phillips Perron test statistic, you can see it is 0.0001%. This one is less than 0.005%. So it is stationary at levels. It is stationary at levels. And look now, looking at the trend, you can see it has a probability value of 0.5703. That is, uh, it is more than the 5% threshold. Therefore, we cannot keep the trend here. Now, looking at the probability value for our constant, it is 0.0434. Of course, this one is less than 5%. So we keep our model with just a trend, with just a coefficient. And if you go back to our table here, you will find that with a constant, yes, with a trend, no, and the probability value, of course, is 0.000. Therefore, it is stationary with the fast difference. That is what we can conclude. It is stationary with the fast difference. Then you go back and do the same for the private investment. So let's see with the private investment how it behaves. Is it stationary in level, or is it stationary with fast difference? Now we are dealing with private investment. That's it. Looking at it again, you find that we are doing with level, with the trend and intercept, and of course it is the Phillips Perron test. Uh, so well, and then let's look at the results. Of course, you can find, looking at the probability value, you can tell that again our private investments are not stationary at level. Of course, the probability value is more than the 5% threshold. Let's look if we can keep the model with the constant and the trend. And looking at the probability value for the trend, it is 0.0149. This one is less than the 0.05% threshold. Also, looking at the constant, it is 0.0277. Again, it is less than 0.05 threshold. So we keep our model with the trend. Therefore, the only thing that we shall record is 0.4412. Then you look at the spreadsheet. That's what I recorded. Then now let's do the stationarity at level. Let's see if it will be stationary at level and whether we are going to keep our constants and trends. So we go to quick, then unit root test, then you specify the variable. It is a private investment, and then you say it is fast difference. Of course, you are going to test it with the trend and intercept to see if it is statistically significant. And look at the Phillips Perron test statistic. It is 0.00. Therefore, it's actually statistically it is stationary now at fast difference. And then let's look at the probability values for the trend and the intercept. Now looking at the trend, we have 0.3900. Of course, you can tell that this is more than the 5% threshold, and the constant also it is 0.859. Again, it is more than the 5% threshold. Therefore, we cannot keep both the trend and the intercept for the private investment, and of course that is what was recorded, but it is stationary at first difference. That's how it is integrated of order 1. That's how we record. Of course, you have to do everything for all the variables. You have to do the same process, and to make sure that now you can ascertain whether it will be stationary at level or it will be stationary with the first difference, so that you can determine is it of integrated of order 1 or is it integrated of order 0. And that's what we have done. So lastly, allow me to do the stationarity test for the uh, change in inventory, because I know that one is a bit tricky. So let's move. We go to quick, and then unit root test. Then you specify your variable. It is that one. Then you specify uh, whether you are to keep the trend and intercept or not, and let's see how it behaves. Of course, it is at level. We are testing at level. And looking at that, remember, uh, we said if it is more than 5% threshold, therefore we reject the null. We do not reject the null hypothesis of non-stationarity. Now, looking at this, you can see with both constant and trend, you can tell that uh, it is non-stationary. But when we looked at at this parameter when we were graphing, you looked at it, and we found that it did not have an intercept, right? And that is a guiding pillar to tell you whatever we have done is not right. Let's test it with without an intercept and without a trend. Unit root test. It is yes, uh, without none. Let's say it has none. Look at the probability value. It's actually less than 5%. And it is statistically significant. Therefore, we say it is stationary at uh, at level, and it is of integrated order 0. So you have to be very, very careful when dealing with some of these parameters. That is why it is important for you to basically graph them to have a rough idea of how they appear before you even do the real analysis. Now, were it not for us doing the real analysis, we would have gone wrong. But don't worry about that, because you can still prove whether the results that you have, they are actually right. And we do that using what we call the filter of hodrick prescot, and that will help us determine that. So next, now that we have, make sure you have whatever I have in my Excel spreadsheet, and so that it guides you. Now that you have all this we have discussed, now the next important thing is for you now to prove that the results that you have on your Excel spreadsheet about the levels and the fast differences, whether they are correct. And the only way you can do that is using what we call the filter of Hodrick Prescott. It tells you, is it an increasing trend? Is it a decreasing trend? For stationary variables, it usually has a constant trend. For non-stationary variables, it will either have an increasing trend or a decreasing trend. So let me just show you one. Uh, we'll go to quick, you'll go to series statistics, and then you'll go to Hodrick Prescott filter. Then you specify we want to see how they behave, our change in inventory. Of course, you say, wow, you can see from the look of it, it has a constant trend, as defined by the red line is the trend. So you can see actually it is a constant trend. It's not an increasing or a decreasing. There is a way that it attains some form of constancy here. So in that, it proves to you now that this parameter will be stationary at level. It is of integrated order 0. Now, assume, let's look at let's try another one. Let's try private consumption. Hodrick prescot private consumption CP. Let's see how it behaves. Okay, of course you can look at it. It has an increasing trend, a rising trend. In other words, it is a non-stationary variable. Now, having said that, you can test the rest, that is to ascertain whether the results that you have for stationarity, they are aligned with the Hodrick prescott filter. Once they align, then you are sure that whatever results you have, they are accurate and they give you correct results. Lastly, now let's try now to predict the exogenous variables. Remember, in our spreadsheet I had left it blank for the years 1998 to 2002 for all the variables. So your task now is to make sure that all these variables are populated. We want to predict in the next 5 years, how will our economy be looking like? Will it be exhibiting some rising trends in some parameters, or do we have a decreasing trend for some parameters? So that's the basis now of a macroeconometric modeling, is for you to focus and to come up with a policy that will aid in particular with the results that you have. So for this exercise now, we are going to determine, to predict, and the only way we can do that is using what we call exponential smoothing methods. And there is a caveat to that, whereby we usually say that for rising or decreasing trend, or for non-stationary variables, we use what we call the non-seasonal halt winters, and for stationary variables we use what we call simple exponential smoothing. So we are going to begin with our first one. We want to predict 1998 to 2002 for our private consumption. So we use, remember, private consumption was non-stationary, so we are going to use what we call the non-seasonal halt winters. And the only way to do that, we go to quick series statistics, exponential smoothing. Then we did specify our variable is private consumption. Then remember, it is non-stationary, so for all non-stationary variables we use the halt winters non-seasonal 1972 to 202, and of course the result that you shall find is CPSM. So click OK, then go back to your window, tile. So we're interested with of course, you can see all the work that I've been dealing with has been saved on my interface. So that's the good thing with the EViews. You can get all the results that you are actually working on. So remember, we have saved it as CPSM. Here it is. So what? Let me go back. Tile. So we were supposed to do something. So let me maximize this. So let's compare our 5-year. We want to see, is it a rising trend or a decreasing trend? So we open it as a group. We want to see our prediction, and then we want to open it as a graph. Let's see how it behaves. There it is. There it is. So of course it is exhibiting a rising trend. This is our prediction. Then again we go and do the same for private investment. Remember, it was also non-stationary, so private investment IP. Then halt winters non-seasonal, the same drill. Go to tile, then IPSM, you open them as a group, then you open as a graph, view as a graph. You want to view them as a graph. Take some time. There it is. Then of course you can look at it. Again, another, it's actually optimistic in its prediction, saying that the private investment will continue exhibiting a rising trend. So you do the same for all of these variables to determine their next 5 years. And then with that, you have now predicted your 5 year horizon. So in the next part now that we have our 5 year horizon, we shall use now that for forecasting purposes. So in the next, the part 2 of this module, that's what we shall be doing. Thank you for tuning in, and I hope if you have any question, kindly reach out. I'm ready to help. Have a good evening.